Good, thank you for having me. Interesting for me to be at a Bitcoin meetup, actually speaking a lot about Ethereum, a lot of the stuff being built actually on Ethereum. My background, just shortly, I'm a theoretical physicist. During my PhD in 2013, I needed to buy a lot of GPU power, and back then the Bitcoin miners went from GPU to FPGAs actually, and I could buy some cheap GPUs. That's how I got into Bitcoin actually, and was wondering what are you doing, GPU mining, and this was 2013. 2014, I got very interested in Ethereum. I started stopping or pausing my PhD, still have not finished it, and worked for Vitalik Buterin at the Ethereum Foundation together with Gavin Wood. So I was part of the team who created Ethereum. 2014 was responsible for the testing and for a lot of things. End of 2015, I created Slockit. We have been working on connecting IoT devices to the blockchain. We heard about a Bitcoin meetup in 2014 New York. I actually also been there, presenting smart door locks which you could open by paying them over the Ethereum network. Then 2016, maybe some of you heard a story about the DAO. Yes, my fault partly. So we basically wrote a smart contract. We did a lot of the work. You can read about it at a lot of places, a lot of misinformation of course as well, some good information. So we went through the ups and downs of this phase of the DAO. After the DAO, Slockit did a lot of other stuff, consulting, a lot of IoT-related consulting. We got some VC money, and recently we got acquired by a company called Blockchains LLC. Just one question, who of you knows this company, Blockchains LLC? Here's some of you. So I just want to make some short remarks. They have been gone public last year at DEF CON in Prague. I spoke about a smart city project in Nevada. So they bought about, I think, 67,000 acres of land. It's a huge, huge land. It's just desert, where they want to build a smart city. It's right next to the Tesla Gigafactory. Samsung, Google, and others are there. So it's actually a nice place to build a city. And also, Blockchains has acquired a couple of bunkers in Europe and US and some other places, which we'll use for custody, meaning key custody, value custody, because we believe that normal end users have a very hard time securing their private keys. So in the end, I believe the best solution is actually using a multi-sig and having some of the keys on your own and some of the keys in a trusted environment like we would offer. In this way, we can set up a system where we are technically not in control of the funds unless you lose your keys. So it's a very nice mix between custodial and non-custodial wallet. This just as a short history of my background. I just have one slide where I want to go through the new tech stack which we are building at Blockchains, and then I just want to speak about one part of it, because otherwise we don't have the time for this. So everything you do on top of a blockchain, you always need private keys. And there will be some keys which we will hold as a custodian, we call them here custodian keys, and some keys you will own on your mobile device, hardware wallet, paper wallet, steel plate, whatever you want. In the middle, you have this multi-sig contract on the public Ethereum net. Here you can set all those nice rules, like let's say you have a 3 out of 5 multi-sig, and one key has this daily limit of up to, let's say, 1,000 euros per day or 100 euros per day, or ETH, you can spend with one key. If you want to spend more, you need 2 keys. If you want to do everything you want, you need 3 out of 5 keys. You can have a white list of addresses who you can transact with, which you can only change with those 3 out of 5 keys. But if it's on the whitelist, for example, then 1 out of those 5 keys can also make a transaction. You can a lot of those smart rules and make your multi-sig or your wallet actually very smart. It's a smart contract-based wallet. That's at the heart of it. On top of this, we are building an SDK, a software development kit, to build applications on top of Ethereum. At the heart of this is the Incubed client, which I will explain later today. We are building an identity solution, which is very linked to the reputation, and a payment solution based on state channels. Maybe some of you know the Lightning Network, which is the state channel network on Bitcoin. On Ethereum, you're much more flexible in what you can actually do inside the state channel network. So that's also something we're building, and something I called Access here is basically all the IoT stuff we have been done at Slockit, we are bringing into this SDK. With this, If you build an application on top of it, you have access to the chain through the Incubed client, which is in Bitcoin would be a Bitcoin client giving you access, just very small. And you have this is like the read access to the chain. The write access to the chain comes to the key management or custody solution or multisig. That's the most important part you need when you want to develop an application on top of. And of course also identity, which is also very crucial for all applications. So if you would build just a user interface on top of, your contracts which run on the public Ethereum chain can directly talk to the multisig contract. So this contract is like part of your identity. And we of course will build a UI on top of this, which you can liken to iOS settings or Google settings, where you can configure your multisig, your identity credentials, who is allowed to see what, but also say, I revoke access to some of my data. All of this stuff will be handled as UI. So if you then install an Ethereum app, it will request access to your multisig, let's say up $100 per day for whatever app you want to play, some game. Then our UI would pop up and you would have to either accept or revoke this need the third party has. The same for identity. If they want to have some identity credentials for you, you have this pop up and say, yes, I will give this data to them or not. So you basically have this nice entry point to the Web 3.0, how I like to call it, because that's actually what we're building. Bitcoin was a really great start, got us all enthusiastic, and now we're building a Web 3.0, which is, you could say, Internet of Value or economy of things, for however you want to call it. But there's much, much more to be built. We want to develop this SDK to build this entry point. But now I just want to talk about one part which is already ready, which we released, which is the Incubed client. And in the end, I will also show you how this also affects Bitcoin, because interestingly, we found out that through this mechanism, which is the protocol behind Incubed, we can actually secure SPV clients on the Bitcoin network. This is actually a very interesting link, that you can get more security in your SPV client through Ethereum. I will get to this at the end. Okay, so what's Incubed? A trustless, stateless, incentivized remote node network. I also like to call it crypto economic blockchain client, or I also like to call it minimal verification client. So if you think about clients connecting to a blockchain network, this is how it should be. A peer-to-peer network, everyone running their own node, accessing a dApp. Each of you have tried to run a Bitcoin full node or an Ethereum full node knows this is not easy. Running it on a mobile or something like this is really not user-friendly. This is how it really is today. Every app just connecting to either Infura or some server on AWS. So if Infura shuts down, a lot of Ethereum apps will shut down too, just because the way they are written, because they're actually not running a node. And this is a problem. With Incubed, this picture will look very, very different. But one word about nodes, because there's often a very different understanding. What is a full node? What's an archive node? What's a pruned node? What's a light client? A full node or archive node, once, of course, downloads the whole blockchain, every block, all the block headers, executes all transactions, and stores all the states after each transaction. Yeah, you can say Bitcoin blockchain is the same, you just have transactions in it. Each transaction changes the state, and you can store it or you cannot store it. Doesn't really matter. A full node doesn't store all the archive node does, like all the traces, every state, not everything. Pruned node what does? I consider a pruned node still a full node because it's executing every transaction, downloads the whole chain, stores the whole chain, but only stores the latest states. So you could think of the difference between full node and pruned is like caching all the states, giving you quick access, but a pruned node technically can give you the same, it just needs to recalculate it. But it already has all the data. But this is way less. You can, I don't know what's the current number, not very long ago it was about 50 gigabytes, maybe it's 100 gigabytes right now, but something in this range. But it's still way too much for a mobile phone or even IoT devices, so we speak about kilobytes, not megabytes. So everybody coming up with a light client. Light client in Ethereum works very similar to the SPV clients in Bitcoin. You download all the block headers, you verify that the proof of work has been done in the block headers, and then you just get a Merkle proof on some transaction you want to have, on some state or something like this. Does anybody know what a Merkle proof is? Some. Okay. It's a proof of inclusion, you could say. You just prove that this transaction or the state is included in this information of this block. So all you need is this Merkle proof, and you need to know what is the right block. That you get by downloading all the block headers and verifying the proof of work. But if you do this, currently in Bitcoin, SPV client, about 4 megabytes per year is what you add. You still need, right now, about 40 megabytes to just store this. 40 megabytes is doable on a mobile, of course, but not on an IoT device. So it's, and of course, the worst problem is actually being connected to the peer-to-peer network. You're sending transaction in blocks all the time. Your bandwidth is the real problem. We did a feasibility study with a German car manufacturer about bringing a light client in a car. The problem was not the storage, the problem was not CPU power, it was bandwidth. Because you're connected to the peer-to-peer network all the time. This is the real problem. So what are people doing? Like I showed before, they just have a remote server somewhere, AWS connecting to it, not what you want. So we have built Incubed to solve this problem, giving you this usability of a remote client, but the security of a light client. So if, right now actually, if you use Incubed, it works like this. Some of those full nodes in the network serving some of those clients, but it's not one, it's many, you can talk to each of them. And they are each other, it's a network which secures each other. And I will explain how this works. So you have decentralized access, and the best thing about this Incubed clients runs on a microcontroller. It needs only 300 kilobytes of memory. This is really microcontroller, less than $2 per chip. And you can connect this to the Ethereum chain and to other chains as well. They're currently working on connecting to the Bitcoin chain as well. This can run on mobile. This even can be run in your browser as part of the website you're downloading. So you can think of, you're opening a website and you're downloading your Bitcoin client or Ethereum client with it, connecting in a decentralized way to a chain. So how does it work? Now comes a short technical part. I think it should be understandable. So on the public Ethereum chain, you have a registry smart contract. And if you want to run an Incubed node, you pay some money in there, a deposit, to register there. Usually those are full nodes or archive nodes. As an Incubed client, you're bootstrapped with this list of active nodes. That's how you start. Later on, you can always update it by asking the chain or those nodes what's the current list in the registry smart contract. So that's how you start off. So you have those nodes, they've paid some money in there, and you have the client who has this list of nodes. This client is not connected to the peer-to-peer network, but it knows this list and how to reach those nodes. If this Incubed client now has this list of nodes, he knows how much deposit each of the nodes in there have paid, and maybe has some reputation, like how quick are they responding, bandwidth, and such things, like the quality of those nodes. He chooses one of them. In our case, it's node B, but important, he can choose any of them. He chooses. He sends this RPC request, or a remote procedure calls, like, what's my balance, or I want to know something from the chain. And he can get a response, a Merkle proof, and block header. But what's the problem here? He doesn't know if the block header is correct. He can lie. He can send me anything. So how do I now secure this block header? This client also sends, we call it validation request. He chooses which nodes should sign the block hash, not node B, very important. He's choosing A and C. They should sign this block hash. This node B then has the task of going to them, could you please give me a signed block hash, node A, then go to node C, and node B knows what's the right block. So if they would be lying, he's like a watchdog, he could go on-chain and convict them in this registry smart contract. He could say, this block hash which you gave me and signed is wrong. I know it because I'm a full client, a full node. So I go now to this Ethereum smart contract and convict you and get your money. So you have to give me the right response, otherwise you will 100% lose it. But what if node B is maybe also a malicious node and they all know each other? First of all, it's unlikely because the client is choosing who's A and C, not B. So it's unlikely. But if it's like more than 50 or 60% of the network, it could happen. We are also running watchdogs, asking all those nodes constantly for signed block hashes, and they cannot really say where it's coming from, this request. So just to check, if any of them would at any time sign a wrong block hash, they would get slashed. The deposit would be gone. So, but with this Incubed client does not have like the full security like a full node had. No, it has we call economic security. It knows by a certain amount, namely the deposit of A and C, how much money they would lose if they would lie to me. So if I have a request about, let's say, I want to open the smart door lock, if there's a deposit behind of, let's say, $50,000, it's enough for me. If someone would lose $50,000 or to lie to me, it's fine for me. So that's the economic security you have. If you want to have a higher economic security, you have to ask not only A and C, but maybe 10 other nodes to sign it. You decide how many sign it and what's the deposit. So that's the concept of Incubed. Of course, this is what already has been built and released. Now what you're currently building through the state channel system is that, of course, the client needs to pay those nodes, because why would they do this? They just can lose money. So there will be a micropayment, fractions of a cent, being paid, and they are, of course, setting the price, how much they want for this, for signing those block hashes. So yes, you have to pay for the security, but it's a really, really, really small amount. So this is how it works for a proof of work chain.
Is this intended for IoT? Because
yes.
It's like really IoT focused?
That's where we came from. Yes, we are running this on a microcontroller, as I said, 300 kilobytes, but it's also perfect for mobile or for websites. Everything where you need very small access. Of course, if you can run a light client, that's better, but then you need to have the bandwidth, the storage, and the CPU to do this all the time. But if you don't have the resources to run a light client, then this is the next best thing you can do. Okay, the nice thing about it, this client is stateless. Except of the registry, it doesn't store anything. No blocks, no block headers, no state. So there's no reason why it cannot connect to several blockchains at the same time. So with the same software, I can say I speak to the Ethereum chain, I speak to the Bitcoin chain, some private chain, whatever I want to. I don't need to update my software for it. I just need to know the registry contract of this chain I'm contacting. That's all I need to know. So one client, which we actually can now call a blockchain client because it's connecting to several blockchains, the real blockchain client. So we have several versions of them. I will not go into the details like different sizes with different features. I will just skip this. We released the TypeScript client, the C client, which is the small one, is a better version, and the Node also in TypeScript. But we are fully going to write everything in C. So embedded C is the language we're using, mostly because that's what's running on microcontrollers. We have done a security audit done by consensus, checking for everything works nicely. Just skip this part. Okay, the sizes may be important. This is for currently guess and parity. The most used Ethereum clients around 60 megabytes, and we are in the kilobyte range. Just skip in, it's the executable. It's only 300 kilobytes. The RAM is 100 kilobytes, and the payload 5 kilobytes. That's really, really tiny. Yeah. Okay. Documentation. I just want to get to the Bitcoin stuff because I'm in the Bitcoin meetup. We built some tools where you can see direct requests handle the network, where you can run your own server. If you want to make some money, you can basically run a server and answering requests, but only after we have finalized the incentive layer, which is not yet, but coming soon. So now getting to Bitcoin. So Bitcoin, you have full nodes, you have SPV clients. SPV clients, they download the block headers, verify the proof of work, and then you get a Merkle proof that some transaction is in. But it's still very big. So if you don't want to be connected to this peer-to-peer network, if you don't want to store those 40 megabytes as a Bitcoin SPV client, what you can do is the following. We run something like a light client inside Ethereum as a smart contract. So basically, it's easy to verify the proof of work for Bitcoin. That's so nice about Bitcoin. For Ethereum, it's actually much harder to verify the proof of work. But we can verify a block header that the proof of work is correct inside a smart contract on Ethereum. If we verify this, someone can challenge, oh, I have a longer chain. I can give you some other blocks which are longer, higher timestamp, more difficulty. And you can basically say, yes, if this is longer, I can prove this on-chain in Ethereum, that this is the longest chain. So you always know what's the longest chain inside Ethereum smart contract. And then you can use the exact same mechanism as I explained for Ethereum to say, well, I just don't store anything as a Bitcoin SPV client. I now want to have my Merkle proof, but I don't know what's the right block. I'm asking an Incubed node, please sign me the latest block hash of Bitcoin. And if it's wrong, it can get convicted in this registry smart contract. So this Bitcoin full node could also run an Ethereum node, paying a deposit to the registry smart contract, which he would lose in case he would sign a wrong block hash. Because we can verify if this block hash is correct inside the Ethereum chain. This really brings Ethereum and Bitcoin kind of together because you now have a secured SPV client secured by the Ethereum network. So this is what we are currently building. It's not done yet, but I think it's very exciting to see what we can do together. Okay, that's about Incubed, so thank you for your attendance. So we have some time for questions, I guess. I was shorter than 5 minutes.
Any questions?
So what was the bandwidth you used for this?
Well, you're only when you ask something, 5 kilobyte. But if you don't ask for something, you're offline. You don't have any bandwidth because you're not connected to the peer-to-peer network. That's also the nice thing. Let's say you only have a request once per year. We had some projects with this as a company. You don't want to run the light client your whole year just because you want to ask something once a year. But for this, you have once a year, there's 5 kilobytes bandwidth and get a response and you're done. And you get it immediately. You don't have to wait for a long time. It's as quick as your internet connection.
That table with the deposits and the ratings, how can you trust it? How can...
You mean this was this one?
Yeah.
Okay. This is on chain on the public Ethereum chain, meaning it's a smart contract.
But you get it from where? Because you're saying you're offline.
In the beginning I said when you bootstrap it, yes, then you need to install it, have in the storage. Like when you start a new Bitcoin node, you need to have some kind of bootstrapping nodes you're connecting to. It needs to be hard-coded or given as a parameter to the client. Same thing here, when you start the Incubed client, you have to give it a valid list of nodes. If you don't do this, it doesn't work. You have some starting point, and then afterwards, of course, you can connect to them and get the updated list with the same mechanism.
That requires a little bit of bandwidth.
Yes. We currently do the following. We store every time there's been a change in here. So when you do a request, you also get the number when the latest change happened in this list. And if it's too long ago, then you say, I want to have an updated list. You don't do it all the time, but only if there's a change.
Properly malicious node first does the right thing, then sends you the wrong list.
But you verify it to the same mechanism. So you know exactly how much. You can ask who should sign this block hash, where this information comes from. It's the same security. Yeah? So you can have low security if there are low deposits behind it, then you're also paying not much for it, or you can have a very high security, paying a bit more for it, having nodes with a lot of deposit behind it. But the security is only the same value as the deposit of the nodes.
But I don't understand, because like I understand the staking, right? But the incentives to lose that depends on something that you don't see. Like it doesn't matter if I lose 50,000 or 500,000 if I can gain 100,000 or 1,000,000.
Exactly. So that's why when I make a request, I need to know what's the economic value of this request. So if this is about to get into my house, I want to have a much, much higher deposit than if it's just I want to know the balance of my account. If it's wrong, okay. So meaning, this is a question, like the security of the model is the amount of the deposit you're asking for.
Yeah, and so if it's a smart lock on my home,
for example,
and it lies, and this oracle lies, and then it loses its stake,
right?
Do I get compensated?
No. You would basically say, if this response I'm getting is wrong, this guy is losing $10,000. That's the only thing I know. So he has no reason to do this except by cheating, he gets more than $10,000 in some way because he gets into my home. That's why the client needs to decide how high is that's why we call it crypto economic security of this response. How much do I need?
Yeah, but if there is no compensation link, then it doesn't matter, right? If I am a homeowner, got cheated, but I don't get compensated.
But the guy lost the money. Yes, sure. Yeah, this is no compensation. This is not part of the protocol. That's why we call it this crypto economic security. You only know the response is valid, and the guy, if it's not valid, the guy would lose that much money. That's the only thing you know. It's an incentive, but it's no full security. If you want to have full security, you need to run at least a light client, if not even a full node. It's not the same security. It's not. But you know exactly what the trade-off is. That's the good part here. Yeah?
So in a practical situation, if I find my house worth $1 million and I put on a smart contactable door, how much do I pay a year if I enter my house once every day? Just to see like an idea like how much am I actually paying to this?
We have to see, because since the incentive layer is not built yet, we don't have the market yet. There will be a market for this, like how much are the nodes requesting you to pay for them to sign the block. We don't know yet. This is a market. There will be demands basically. It's a free market. Let's see how much it will be, but also it's important to know you don't have to ask each time you enter into the house. If you, for example, know you have the right for this for the next 2 weeks, and you have this response already, then it's valid for 2 weeks, because you know the contract cannot change, for example. So you can do a bit smart stuff about it. Like people always thought when we stand in front of the smart lock that you would have to make a transaction. You can do this way prior, just sending a Bluetooth message, getting verification, getting it back. So there's a lot of optimization which can be done. But the smart lock is just an example we always use because that's what we started with. We are not building smart locks. We are actually focusing more on generic, on IoT, and also on mobile wallets and other things to integrate this client.
Go back to the car. If I will implement this in my car.
Yes.
Could it be automatically updated?
This is just the software, yes. You can write a software which downloads it from our servers, the latest version, yes. Of course. But in the car, it's a nice thing because the car could then pay and get payment. So we have this dream about machine-to-machine payment. Let's say the car is paying the charging station. If you have like a red traffic light, you have induction, and you're just paying it, and then you continue.
Per kilowatt?
Yeah, you pay per kilowatt with a state channel solution on top of Ethereum. You can do very quick payments. And here's just getting information if this is validated or not. You can do a lot of cool stuff with this machine-to-machine payments. Or machines paying humans, like changing tires, for example. If this red light goes to green again, I get a payment from the car. And so this autonomous cars really only can work if they can pay.
Machine-to-machine economy, but
Exactly.
also human-machine economy.
Or human to machine, we pay a machine, the machine does something for us, all those payments. Because virtual currencies are the only real cash for machines they can actually use. Not just an API to PayPal or MasterCard. They need real cash on hand as a machine. That's the only way to do it.
Okay, I'm very sorry, I have to cut this short.
One more question.
Yes.
And we need to get at least one DAO.
One DAO question? Sure, give it to me.
I'm curious to hear about your, say, personal experience, having lived through this, really critical moment
Sure.
in the history of the industry. What was kind of going on in everyone's head at the time when they had that very difficult decision to make, to fork or not to fork?
This is a long question. How much time do you have?
I think I suggest there is a drink after.
But I think
we will continue, but we should say something.
Okay, should say something about it. So the thing is, nobody wanted to make a decision. And in some sense, even though it did appear a bit differently, they didn't really make a decision. Neither did the foundation make a decision. The only decision which was made, because of a vote going on the chain, which only a few people voted on, was to offer the option. This was the only decision really being made by developers. So for me, this time, I felt like orchestrating a group of people who always didn't want to do anything. So the foundation didn't want to act. Vitalik never made a decision and didn't want to, and I respect this totally. So I basically asked this developer to basically put in the option of the hard fork. He said, if my boss tells me, the boss says I have nothing to do with it, so talk to him. So nobody did want to take any responsibility for it. So in the end, because of this carbon vote happening, he said, okay, it's also not good if we don't give this community at least the option to hard fork if they want to. So they put in the option. And most users decided to go with it. Of course, this is a very, very, very short story. There was much, much more to it, a lot more meetings, a lot of opinions, a lot of philosophy about what is a blockchain, should it be immutable or not. In the end, every blockchain can be changed through a hard fork at any time by its users. It's just how it is. Nobody expected Ethereum Classic, at least not me. It's a very long story, but I respect everybody's opinion. I fully understand the Ethereum Classic guys. It's the mindset. But on the other side, it was very, very, very early in Ethereum history. Some people argue it's like a better version. Like the history of Ethereum.
Do you really mean nobody expected Ethereum Classic?
No,
nobody?
Not nobody.
Really?
No, of course there are people expecting it, but not many. Like the people that I talked to, they didn't think of it.
A group of 50 on the Skype channel. No one.
Something like this, yeah. We didn't really.
one.
I will not like my hand in fire for this. Maybe. Yeah. I don't recall anybody taking this as a serious thing to happen. They maybe thought as a theoretical option it could happen, but nobody did take it as seriously. I was surprised by it. Of course, it's an even longer story about Ethereum Classic, how all those guys came on to buy our ETCs before the chain was actually live at any point for 1 cent per ETC, and this Kraken exchange, a lot of stuff happened there.
Will you come back again and talk about it? We'd like to hear it.
With a campfire.
It's a long, long story. I think one last remark. The best talk about it you find on YouTube for Aracon conference. I gave a 20-minute presentation about the history of the DAO where I reveal almost everything. So if you go online, you can go there.
Thank you.
Thank you very much.
Okay.